The rule for multiplication and division is actually a different rule than addition and subtraction. And the rule for multiplication and division is that we use the least number of sig figs out of the numbers that we are multiplying or dividing. In subtraction and addition, the decimal took center stage and really mattered as far as how things were rounded. The decimal doesn't mean anything in multiplication and division. We don't care how many numbers are after the decimal or anything like that. All that matters are the actual number of significant figures in each number. Whenever we're multiplying and dividing, we're doing the exact same thing with the units as well. So the first example I gave you there was 10 meters times 10 meters times 10 meters. And normally we would multiply these numbers 10 times 10 times 10, which is 1,000. And meter times meter times meter is going to give you meters cubed as a unit. So you can see how that unit, we did the exact same thing with the numbers as we did with the units. Another example I gave you was 25 grams divided by 5 milliliters. That's going to give you a number answer of 5, and the unit answer would be gram per milliliter, just gram over milliliter, or gram divided by milliliter. So it's important that you do the same thing with the units that you do with the numbers. Rounding can be pretty tricky with multiplication and division. Typically, it's still the same rounding rule that we use 5 or up, and we round the number up. The difference is if our number is greater than 10, we're going to have to zero out the number. So we don't want to just cut off the number anymore. We actually want to zero out the number. Let me give you an example. Let's say we had the number 1,538 and we had to round that to 2 sig figs. I would normally count over 2 places and draw my line, which means my 3 is determining rounding on the 5. And based on our rounding rule, 3 is not going to round the 5 up. So I'm going to keep the 1 and the 5, but because this number is greater than 10, I'm going to actually zero out this number, which means the 3 is going to turn into a 0, and the 8 is going to turn into a 0. So 1538 rounded to 2 significant figures becomes 1500. Another example I gave you here was 16. So let's say we have 16 and we want to round that to 1 sig fig. We'd count over 1 place and draw our line. So that's normally helps us with what number is going to determine rounding. In this case, the 6 is going to determine rounding. Now 6 is greater than 5, so we're going to round the 1 up. So that 1 is going to turn into a 2. But because 16 is greater than 10, the 6 gets zeroed out and turns into a 0. So that means 16, sorry about that interruption, so 16 rounded to 1 significant figure turns into 20 as our answer. So that's something that can be pretty tricky about rounding with multiplication and division, or rounding period when it comes to significant figures. Let's look at a multiplication and division example for actual doing sig fig counting. 2.6 times 3.78. Remember, we don't care about the decimal in multiplication and division. All we care about is the true number of sig figs. So 2.6 has 2 sig figs in it. 3.78 has 3 sig figs in it. The least number of sig figs out of these two is 2. So that means my final answer needs to be only 2 sig figs. When I type these numbers into my calculator, I get 9.828 as my answer. Now I only want 2 sig figs in my final answer, so I'm going to count over 2 places, and then I'm going to draw this line, and that's going to help me determine what number is significant for rounding. This 2 is the important number for rounding. 2 is smaller than 5, so we are not going to round the 8. We're just going to cut off the number after the 8. So our final number then becomes 9.8. And notice that is in fact 2 sig figs. Okay, let's take a look at another example. 3.15 times 2.5 times 4.00. Since this is all multiplication or division, we're going to go ahead and just count the sig figs. 3.15 has 3 sig figs, 2.5 has 2 sig figs, and 4.00 has 3 sig figs as well.
100 Hall is released.
Sorry about that interruption again. Let's start over with that problem. Okay, we have 3.15 times 2.5 times 4.00. And again, what I was saying is it's just the number of sig figs that matter. That number is 3 sig figs, 2.5 is 2 sig figs, and 4.00 is 3 sig figs. So when I multiply this out together, the number that I get is 31.5, and out of all of these, 2 is the smallest number of sig figs. That means that I need to round this number to 2 sig figs. So I'm going to count over 2 places and draw my line. This tells me that this 5 here is the important number for rounding. And 5 is going to round that 1 up to a 2. So this is going to become 32. And then we're going to cut off the number. And sure enough, 32 is 2 significant figures. So that's how we do a problem like that. I have 2 more problems on the sheet that I want to run through with you. The next one is 0.058 divided by 2.10. Because there's no addition or subtraction and this is a multiplication or division problem, it's the number of sig figs that are going to matter. 0.058 has 2 sig figs, 2.10 has 3 sig figs. So when I put this into my calculator, I get a number like 0.027619 and then a bunch of other stuff. Between these two, I can see that 2 sig figs is the smallest number of sig figs. So that means I need to round this number to 2 significant figures. And normally we count over 2 places, but because of this 0, I'm going to skip that 0 and then count over 2 places because leading zeros are not significant. And then I'm going to go ahead and draw my line, which means that 6 is going to be the number that determines rounding. And 6 we know is a number that is going to round the 7 up. So we're going to end up with 0.028 as our answer. So 0.027619 blah 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 turns into 0.028 for 2 significant figures in that problem. Okay, let's take a look at one last problem. That's 0.0006 times 800 point divided by 120. And because this is all multiplication and division, we're going to count out the number of sig figs. This first number has 1 sig fig in it because leading zeros do not matter. And the second number actually has 3 sig figs. This is kind of tricky because this period after tells us that we do need to count these zeros as significant. And the third number has 2 sig figs in it. When I multiply this out in my calculator, I get the number 0.004. And when I look at all of the different numbers of sig figs I have here, the least number is 1 sig fig. So my final answer needs to be rounded to 1 sig fig. Sure enough, this is already 1 sig fig, so I don't need to do anything else. So that number is good as it stands. I want to bring just one more thing to your attention really quickly. Let's pretend that the number that we got out was 0.004, and let's say that we needed to round that to 2 significant figures. The way we can round this number to 2 significant figures is by adding a 0 at the end. Right now it's only 1 significant figure, so by making it 0.0040, notice that I added a 0 on here at the end. That made that number 2 significant figures. So you'll see every now and then you may have to add a 0 at the end of a number in order to get the right number of significant figures.